And it says, "We are live. We are live, streaming live onto Rumble, onto YouTube, and I don't know if and Facebook. I am Julian Catari. I'm the presenter. I'm presenting this conversation. This is I Need Living Conversations. This is the 148th conversation. I am with Blue Heron Women, and every week we get together to share some insight on the Owl Dojo investigations, on the many investigations that or that Blue Heron Woman leads with her Aloha I Need Owl Living project, which is a project to free humanity and to free you from slavery and to reach wholesome plenitude. And so all of the topics we cover and the investigations that we participate in have to do and help out in guiding us with knowledge and wisdom on how to get to that freedom and how to build this Aloha I Need Owl Living kingdom of how many ranches?
Oh, we're starting with 8 and 3 palaces.
8 ranches and eight
And
ranches
3
and 3
palaces.
palaces where you will be able to have a complete wholesome life in complete freedom without any confusions of the mind programming of the new world order system that we live currently. And so today's topic, the secrets of air, is to me one of a very fascinating topic. I'm very excited about it because I love the contrast of something that we would think is so common and that we would think we are so familiar with, like air. How much do we really know about air and what happens with air? And I'm guessing that's something that's going to be coming in this conversation. All the intricate things that happen with air and organisms and maybe chemistry and a whole bunch of things, but things that most of us don't really know or don't really pay attention to. So that's why it's the secret life of air. So welcome everyone. Take a good seat and get ready for this journey into wisdom.
It's also the restless shaper of our world, air.
Wow, yeah. Okay.
So air can't be owned, it can't be controlled, and it can't be contained.
Okay. If I put it in a jar, it's not contained?
Nope.
Okay.
It has no borders or boundaries. It's hot or cold, thick or thin, heavy or light, wet or dry, as it pleases.
Wow.
It appears at will. It spins, it rises, it falls, it swirls, it spurts, it mounts up, it swoops down, it expands, it contracts, it tumbles, it jets, it sprays, it mixes, it flows, it sinks, it stays, and it rests. All at the same time sometimes.
Yeah.
It is as quick to change as dirt is slow
Wow.
to change. It penetrates the soil. It mixes in the sea. It can stand human plans on their heads, or it can sweep them out the door like dried leaves. It changes the world. It challenges the fate of creatures and the destiny of peoples.
Wow.
The air is a single moving fluid that stretches from the heavens to the earth. The higher you go in the air, the less there is of it, yet it never ends.
Mm-hmm.
Almost all of the moving fluid of air, however, is found within 60 miles of our Earth's surface. At the surface of the Earth, that thin, all-encompassing sphere of air weighs about 500 trillion tons, enough to drive it deep into soils and diffuse it into water. Oh, nothing breathes water, in case you're wondering. Nothing breathes water.
Not fish?
Fish and all the flora of the ocean extract their air from the water. They don't breathe water, they breathe air through the water.
Okay. Wow.
Right at the surface of the earth is a microscopically thin layer of air that the force of friction keeps almost completely still. Nowhere else is the air ever still. The air is the theater of our world, and it is the strangest of creatures. It creates and is created by its actors, and it is both stage and actor. And all flesh is made up from the carbon dioxide in the air. All creatures breathe it in to sustain their lives. It makes, delivers, and drops the rain and snow that vivify all life on Earth. It carries spores to new homes, pollen to waiting antlers, and insects and bats and birds to one another. It also brings the pathogens and decomposers that decay the dead or destroy the living. It carries the pests that devour a crop of corn or kill 300 billion or 30 billion trees. The air stirs the pot. It changes its course over the face of the earth, and where once rain fell dependably at a certain season, it suddenly does not fall at all, because the air thickens the plot. Twice the Mongols invaded Japan, their fleet mauled by typhoons. And in 1588, the Spanish Armada is destroyed when an all-powerful Atlantic storm piles up more than half their fleet on the rocky beaches of Ireland.
Wow.
So the air is the great stage. Odors rise and waft through it. Chemical signals so transmitted are the most widespread form of communication on Earth. Living beings make and sustain the theater of air. Using water vapor from the air and soil, carbon dioxide from the atmosphere, and energy from the sun, plants make both the structural components of their cells and the food to feed themselves. One step in the process releases oxygen into the air, and most of this is inhaled by the animals and us and taken in by plant cells, both of which give off carbon dioxide. Photosynthesis and respiration would balance one another were it not for death. Most of a dead thing is dissolved into air again, but some of it is not. Some cellular carbon is buried in the soil or sinks through the water to the bottom of the sea, where it is effectively entombed, more effectively entombed than in any grave. The release of oxygen in photosynthesis then exceeds the release of carbon dioxide by respiration. The atmosphere is about 20% oxygen because of the dead.
Wow.
Yeah. The theater of air covers the whole world. It has no walls. It doesn't have a roof. Oh no, it does have a roof made of oxygen, but it has no walls. Ultraviolet radiation blasts cells apart, and when the usual double oxygen molecule rises to the top of air, it absorbs this radiation and the molecule is blasted apart. It may recombine into another dioxygen, or it may make trioxygen, which is better known as ozone. Right, so we all know oxygen is O2, two molecules of oxygen, right? So it gets blasted apart and may recombine to make another dioxygen, or it makes trioxygen, which is ozone. This drama high in the air creates the roof of the world. So not only does oxygen shield living things from ultraviolet rays, it also caps the restless motion of air. It is the rule of life that a warmer fluid rises through a colder one, but not vice versa. So cold doesn't rise through warm. So when warm is on top of the cold, it makes a lid on top of in the air. When oxygen absorbs radiation, making ozone, the temperature rises. From an average 57 degrees or 14 degrees Celsius at the Earth's surface, it is now minus 71 or minus 22 Celsius just below the ozone. However, from the bottom to the top of the ozone-making stratosphere, the temperature rises 28 degrees. Only, doesn't. So weather can't push through the warm worldwide inversion. The fast-rising columns of air in the strongest summer storm cells punch up into the ozone layer, but they can't continue to rise through it. So the clouds bob like a cork in the ocean, and the anvil-shaped top of the biggest thunderheads mark the place where the rising air hits the stratospheric roof, the ozone layer. More than 78% of the gas in the air is nitrogen. Like oxygen, it usually occurs as a double molecule, and unlike oxygen, it forms a strong bond with itself and remains uninterested in other combinations. And without nitrogen, the living have no proteins, no enzymes, no behavior, no reproduction, no skins. And then if there's no death or no decomposers, the nitrogen would build up in the dirt and desert the air. So beneath this roof live all of Earth's actors, and the air is the freest of us all. As both the stage and the actor, it is the absolute archetype of freedom. From one point of view, we know very well what air will do. It will get cold in the winter, hot in the summer, warm and cool in the spring and fall. Rain, snow, or hail will sometimes fall. Fog might form, or heaps of clouds might form. The wind rises and falls. However, what we don't know in advance is when these events will occur, or where, or how much, or how little weather they will bring, or what the results will be. In the same way, we know that a person is born, lives a life of a certain age span, and faces the same needs to eat, to live, and be loved, to age, and to die. But what will exactly become of the crying, puking infant is beyond the skill of anyone to predict, and that is freedom. Air is set in motion when the sun strikes the sphere of the Earth. Near the equator, the sun strikes more directly, and near the poles, it strikes more obliquely. So at the equator, it gets heat up more than at the poles. Air that is hotter rises, and as it does, it flows north towards the cooler regions, and so as it does so, it cools. The rising air near the equator lowers the pressure beneath it at the planet's surface, and the colder air from the poles is denser, and so it's under greater pressure. Warm air heads north way up there and cools. Cool air heads south beneath it and warms. As our Earth spins during this exchange, the air is deflected west or east according to what is on the face of her. There is a supple and irreducible order to nature, like similar but never identical patterns in the air, and it works itself out as a story of adventure, whose end is not known and whose purpose is only surmised as we reach the end of each cycle. In such a world, wonder, not certainty, is the great joy. Yet so much of our response to adventure is to control and eliminate it, because it brings uncertainty and maybe some danger. So air in every moment is a special gift, the archetype of restless immanence. It is full of invisible movement and invisible contents. Through what it does and what it brings, it makes and unmakes the world it envelops. There is no actor more powerful on this earth, and yet for the most part we ignore it. Both the air and the rest of us are not problems to be solved, but mysteries in which we live. We can't control the weather, but the weather changes as we change the contents of the air. All that is alive exchanges gases with the air by means of the phenomenon of breath, and whatever we breathe out is breathed in by some other living being. So the energy to live is derived from these exchanges.
Wow.
Darwin's dust.
Mm-hmm.
Charles Darwin began to realize that dust events are not only as common as dirt, they are also as important as dirt. So in 1832, when he was on a ship about 310 miles west off the coast of Africa, is when he discovered that. And it was a gray, hazy morning as he paced the deck, continually looking at the weather vane to see if they had shifted position. Finally, he noticed that the weather vane seemed dirty, and he asked to see it. He later reported that the gauze of the vane had filtered from the hazy air an excessively fine-grained dust that was of reddish-brown color. From the persistent wind and character of the dust, he decided it must have come from Africa. And then, the wind gave him another gift, a large live grasshopper. And at this point, they were about 370 miles from Africa. So how did that happen? He sent samples of the dust to a microbiologist in Germany. The microbiologist reported that the red dust contained not only soil, but soil minerals and spores, bacteria, pollen, grains, and silica. We have since learned that this dust supplies much of the iron, calcium, and phosphorus that the ocean's plankton need to live. But not all the dust falls into the sea. It reaches Brazil, the Caribbean islands, Florida, Georgia, Alabama, and the Carolinas. And it comes not just in dribs and drabs, but by the ton, about 1 billion metric tons a year. The Sahara Desert and the Sahai, a savanna that is becoming desert in regions of Africa where it is very wet, is where all this dust comes from.
Mm-hmm.
Here, the globe's warmest and wettest air rises, creating clouds as it cools and forming huge successive rainstorms. Once the air is done rising, cooling, and dumping its load, it subsides both northward and southward in the subtropical storms or zones, creating very high pressure, little rain, and almost all of the world's great deserts, including the Sahara and the Gobi.
Mm-hmm.
Throughout the dry Sahara and Sahai, small-scale convection caused by heating of the ground raises the dust into the troposphere, the sphere where changes where all weather takes place. In the winter, the storms push the dust into the Atlantic trade winds, where it blows straight across the ocean from northeast to southwest, arriving after 5 to 10 days in northeastern Brazil. There, the dust-laden air collides with large-scale convection storms, entraining the dust and increasing the scope and power of the storms. And as summer approaches the northern hemisphere, it now moves north, shunting the lifted dust into the expanding cyclonic wind of the Bermuda Triangle. The dust floats northwest in that clockwise flow, arriving in the Caribbean and the American Southeast. Without this dust, there would be no rainforest in Brazil.
Mm-hmm.
And it has been doing this a very long time. So the soils of the rainforest are very old, and the rain leaches the nutrients through them very quickly. Phosphorus, one of the first nutrients to be exhausted, is virtually unavailable in those old soils. Only the annual transport of dust from Africa brings the crucial mineral and so permits the great trees and their colonies to grow. Scientists say they believe the dependence of large ecosystems upon each other, even though separated by oceans, yet coupled by the atmosphere, it's fundamentally important to how the global system functions. So the main provider of the clay minerals and of phosphorus are wind-borne dusts. Half the desert that blows around the world comes from Africa, another quarter from the Gobi Desert in Mongolia and the Taklamakan deserts in China. The Gobi and its phosphorus-rich dust renew the soils of Kauai. So, what's the point of this? Our world is not an aggregate of stable individuals, but a network of processes out of which individuals arise and into which they return. The world is a concert that brings forth its own instruments. The world born of this dust is one that survives both from strength and from weaknesses. The fitness of the winds is that they are strong enough to carry fertile dust 3,000 miles and further. The fitness of the rainforest is that they are able to receive it and transform it into trees. And that is absolutely Aini.
Mm-hmm. On a global scale.
Yes. There is far more life in this world than we are accustomed to believe. The air is alive with invisible travelers, the spores, the fungi, the rafts carrying bacteria, and drifts and rivers of pollen grains. The only reason our world is not awash in the dead is that the fungi return them to Earth. We see them only when they settle and fruit, making mushrooms, the fungi. They really are a lot more like us humans than plants. They live on the flesh of others They're cosmopolitan. They spread to every habitable niche in the globe. And we spread the spores of fungi in and out all day, every day. There are 10 to 15,000 spores of fungi in the average cubic yard of air. And after a good summer rain, that number might rise to almost 1 million. Fungi shoot their spores, or splash, or blow, or drop them. Wind-pollinated trees and grasses hold their pollen up into the wind, yet bacteria do nothing. In fact, a gale wind will do very little to carry a single bacterial cell into the air if that cell is not otherwise attached. So from the point of view of bacteria and of everything alive, the good news is that the bacteria are always attached to soil particles, to mineral and to organic dust, to bits of leaves or bark, to skin cells, to fibers, to oil drops, to saliva, to hair, to spores, to bursting bubbles on the surface of the sea. So bacteria do get born into the air. Lifted and lofted on every kind of substrate, indoors and outdoors, large numbers of bacteria end up in the air. An estimate of the total number of cells in the air around our globe each year is the number 1 with 24 zeros after it.
Can't even name that.
Yeah, you can't even name that. Like fungi, many bacteria fall into the soil where they keep us from being overwhelmed by the sour dead. And the bacteria preferentially digest fresh green materials high in nutrition. They're nitrogen, not nutrition. They're also attracted to the root zones of plants, and it is only through the work of certain bacteria that the relatively inert nitrogen of the air can be captured for use by us living beings. The vocation of many bacteria is to live in the soil, but some not only travel by air, they live in the air. A bacterial cell can stay in the air for a few hours or up to a few weeks, depending in part on when and where it rains. Viable bacteria have been found 35 miles up in our atmosphere. High in the clouds, some bacteria help generate the ice nuclei that lead to rain and snow. So bacteria then do double work in the great terraqueous machine. While underground, they compost the dead, they protect roots and fix from the air nitrogen without which a single amino acid or nucleic acid can be made. So without bacteria, we can't have protein. Aloft in the clouds, they create condensation nuclei and so affect the amount and frequency of rain and snow. They are the smallest airborne creatures needing help to get aloft. Pollens, on the other hand, are the giants of the invisible world of air. Pollen is tough on the outside, but tender on the inside. The outer layer of the pollen shell is one of nature's most durable coats. You can cook it in a 500-degree oven or bathe it in acid or lye, and it will come out looking just the same as when it went in.
I didn't know that.
The insides, on the other hand, live as briefly as a few hours and never more than a few days, no matter how they are protected. They contain a male nucleus that fuses with a female to make the embryo, as well as 2 additional nuclei that fuse with another nucleus in the female to make food reserves for the embryo. And finally, the insides contain hormone shots to tell the female that it's time to make fruit. In the course of eons, nature seems to have thought of better alternatives than wind pollination, designing numerous plants that attract insects to care for their pollen for them. And the insects know what flower they came from and what flower they are going to. Were natural selection a matter of simple efficiency, one would anticipate the withering away of wind-pollinated plants, but yet they remain the anchors of our world's flora. The boreal forests, the temperate forests, and the great grasslands and savannas are all based on wind-pollinated plants. Mostly pollen falls within 25 to 50 miles of its point of origin. So the air is weaving. Like a piece of cloth, it shows a beautiful pattern, but you have to look very closely to see the weave by which it is made. The air is the weaving of gases and ground. When rain or snow falls, it is seldom that just water comes down. It's a solution of water with the dusts, the liquids, the smokes, the microscopic organisms that have risen from the surface of the earth. What smells in a flower, a forest, or a fart rises into the air and condenses into liquid particles. So when you fart, it rises into the air.
Yeah. We make our own air.
Yeah. Forest fires and volcanoes add to it. So do power plants, car and truck exhaust, smokestacks of ships, the contrails of planes. All of these particles in the air are called aerosols, which means dissolved in air. Depending on how full the air is on a day, the aerosols number between 74 million and 299 billion. Among that number are droplets of fat. The most common aerosols in cities emitted by restaurant chimneys and food trucks is fat. By no means is the air ever empty. There might be fewer aerosols on a calm day in midwinter, but there's never none. You and I breathe all of them in and out. So around the world, there are 1 billion metric tons of organic aerosols in the air each year, with another 5 billion tons of mineral dust and 3.3 metric tons of sea salt. And there are likely between 10 to the 22nd power and 10 to the 24th power of bacterial cells in the air at any one time also. And more than 50 million tons of fungal spores travel by air each year. So if we think there's nothing in the air, we're full of it.
The air is full of it.
Yeah. In most of the temperate world, cloud droplets and crystals, the precursors of rain and snow, happen because water and aerosols become one. Each cloud drop is a solution of an aerosol with water. The amount of water vapor in the air because of the aerosols has increased by 5% each year in the years since World War II. And so this is a lot more fuel to make bigger storms. So part of our big ass storms is because of what we're putting into the air.
Mm-hmm.
Spin drives the power of storms. The spin might be a twist that a passing jackrabbit starts in the hot, dry desert air, or it might be a dust devil that spins and lifts a kangaroo rat 50 feet into the air before dropping him, highly pissed off. Mm-hmm. Or it might be as large as the 1,000-mile diameter counterclockwise spinning cyclone that crosses whole continents. Spinning storms represent the freedom of air, but what happens in their wake is unpredictable. Every storm transforms heat and energy into mechanical energy. The warm rising air and the cold sinking air acquire a spinning motion. And to conserve energy, the motion must be spent. If it were all spent as wind, we would live with an average winter wind speeds above 100 miles an hour. Mm-hmm. But the spins lift vapor, condense it into the water, and then spill it again. The evaporation uses some of the mechanical energy, but more is dissipated in the friction of falling rain and snow. Did we know falling rain causes is friction?
No.
I didn't. The counterclockwise cyclones keep the whole atmosphere in motion. In the northern hemisphere, the air moves in general from west to east. Clockwise spinning anticyclones have high pressure at their center. They bring sinking air and clear weather. Counterclockwise spinning cyclones have low pressure at their center, and they bring precipitation and wind. So the anticyclones, which are the clockwise, make ridges in the moving air, and the cyclones, the counterclockwise, make troughs. The spins lead to the big winds, tornadoes, and hurricanes that are infrequent. Really, it doesn't seem like they are, but they are the strongest because of the particular combinations of temperature, pressure, and wind that creates these spins. The strongest winds naturally occurring on the surface of the earth at almost 300 miles per hour are found in the biggest tornadoes. They come from a vortex with runaway lightning or tightening, where the inward and outward tending forces of the spin collapse toward the center point and rapidly accelerate the motion. And there are only 2 regions in the world where tornadoes are common. One encompasses Bangladesh and northeast India. The next one is in the American Midwest. And both regions lie east of a major mountain range and north of a warm ocean. The combined influence of the two is what drives the intense and slender spins. In the spring, as the world is warming, the prevailing westerly winds force air up the west side of the Rockies. The air cools as it rises, so precipitation may fall. The air loses much of its moisture and is dry when it passes the summits of the ranges. On the east side, the air flows back down the slopes, and when it does this, it compresses and warms, spreading out like a blanket over the Midwest. Meanwhile, the southerly winds bring the very moist air of the Gulf of Mexico northward into the region. This air is cooler than the air flowing down from the mountains, so it filters in beneath the warmer layer, and now we have the stage for severe weather. Dadgum from the Gulf of Mexico. The first ingredient you need for a tornado is a lot of energy in the air. So when the warming mountain air lies over the slightly cooler, wet Gulf air, the situation is pretty stable as the day begins. As the day warms, however, the sun heats the ground and the moist air gets warmer. The low-level air heats and begins to rise, pushing up against the still slighter, warmer, dry mountain air above it. So when the rising, warming, wet air is warm enough, it bursts through the cap of mountain air and sails upward all the way into the stratosphere. And as it rises, water condenses and releases energy. So now towering clouds form, and the energy contained is absolutely tremendous. Multiple large thunderstorms are what tornadoes need in order to form. There also has to be spin up high in the storm, and that spin needs to meet a low spin. A hurricane, like a tornado, is produced by a very particular spin, but the spin is unlike the tornadoes. The peak wind speeds are a third less than those of a tornado, but the hurricane's spin covers a lot more territory and lasts days instead of minutes. Most Atlantic hurricanes begin with the warm, dry air of desert Africa flowing over the cool, wet air of the Atlantic. And so the meeting of the two makes a kink in the air, and this pushes moist air upward. Its vapor condenses and creates more energy. Everything that happens in the air has to do only with whether the air is rising, what the pressure is, how the wind is blowing, and what the temperature of the air mass is, and how much water vapor is in it. That's all we need to know. Mm-hmm. Very simple, right? The dew point of temperature is the temperature at which the air would be fully saturated with water. When temperature and dew point meet, clouds form, and it is a good bet that rain or snow will fall. So when wet air rises, clouds come. 20% of the solar energy that reaches our Earth bounces back into the atmosphere. This is the largest transfer of heat on this planet. When the air warms, it vaporizes the water and carries the gaseous water high aloft. As it rises, it cools. And when the gas has cooled to its dew point, the vapor turns it to droplets again, and clouds appear looking like wisps or ragged gray blankets, or like piles of pillows, or like rolling seas. Weather forecasting is not about familiarity, as the exact same weather conditions have never recurred in the history of the planet. We are immersed in a world where the smallest unobserved change could make the difference between the sunny day and the massive storm. Rising pressure usually indicates that the arrival of air will subside. Suppressing clouds and providing fair weather. Falling pressure usually indicates the coming of air will allow the vapor to rise, producing wind and precipitation. So rising pressure is good, falling pressure brings storms. Wind and rain in any local area depend largely on whether the air is rising or falling and on whether it's wet or dry. Simple. Is it rising, falling, or wet or dry? So much depends on the water in the air and whether it cools enough to come out of hiding so you can see it and feel it. Now, a firestorm is aptly named because it occurs when a fire creates its own weather, a set of violent updrafts that create more weather or more fire. Everybody comes out of a womb, but nobody remembers it. Yet from that moment on, we are creatures of the air. The senses are the means by which we come into communion with our world of change. Sound is a pressure wave that radiates from its source. Smell can be complex, but it is instantaneous. It affects us through its mixture and strength. Sight and sound share a canon of beauty, an irresolvable and inexplicable order that gives more than it takes. So the exquisite adaptation of living beings to a place they must live in is an adventure. Breath turns a place into habitat. If you can breathe there, you can live there. The natural variation of life is the element of adventure. Natural variation goes where none has gone before. Breath requires an exchange. So how much breath is in the air around us? Well, if we walked around my farm and took each creature we saw as a representative of its species and multiply it by the number of its species around, and add all the various creatures together, we'd probably get about 19 million breaths per minute.
Wow.
Mammals breathe 650,000 gallons of air each day. The birds about 30,000 gallons, and reptiles and fish about 450 gallons. So the atmosphere is regulated by the living. From air and water, all the living are derived through the medium of breath.
Mm-hmm.
Breath is the difference between life and death. And there are only 3 places on Earth that a creature can live: in the atmosphere, in the water, or in and on the dirt. Air penetrates all 3 and is in all 3. And the air is regulated by breath. And breath does not belong to anyone. A breath contains oxygen, nitrogen, carbon dioxide, and a variety of other compounds. Dust motes, pollen grains, bacteria, dead skin, plant hairs, and spores. Yuck, my breath contains all that? Though no one owns breath, there is a matchless pleasure to breathing. There is also a compulsion. Breath as an action has a result. It creates an atmosphere. In the largest sense, the troposphere, that part of the atmosphere where the air constantly changes and where the living live, is the product of all our respiration and photosynthesis. So the air is not a thing or a place. It is the continual product of communion. Breath is a measure of life. So 3 minutes after we stop breathing, we are brain dead, and in 6 minutes, we're stone dead. The wind, the enveloping, ever-moving atmosphere, is exactly where our breath comes from. And so by entering into our bodies and exiting again, we join a community that has been producing and sustaining Earth's air for a very long time. Wherever there are plants in the world, the sun powers the ascent or the sap, and so sets in motion the processes by which all creatures live. Trees are the largest, the most massive, and the longest-lived creatures on Earth. 1/2 of the organic carbon in the world is cellulose. Another 1/4 is lignin. And these 2 polymers weave the nets of cells that keep trees bending and standing in the air. Trees make 250 billion metric tons of sugar every year. They're heavy, solid, stable, and persistent, and they never move until they fall. The air is quick, transparent, ephemeral, ever-moving, ever-changing, and never still. Yet joined together by the sun, trees and air are the planet's greatest symbionts, or Ini, creators. They form a community of Ini. They depend on each other, they feed each other, and one of them cannot exist in actual form without the help of the other. So what does a tree give to the air? Water and oxygen. The tree transports liquid water from the ground, pumps it through a labyrinth of tiny pipes, and emits it as a gas water vapor through the stomata, tiny holes on the backside of each leaf. An oak leaf has probably 9,000 stomata per square inch.
Mm-hmm.
And a good mature oak has maybe 90 million leaves. So in the air, water vapor from the trees becomes clouds and future rain or snow. When it condenses into clouds, it releases heat energy that propels the circulation of the atmosphere. So the power, the pattern, and the range of storms are in large measure the gift of trees and plants to the air. And trees and plants produce all of the free oxygen in the air by means of photosynthesis. Oxygen makes ozone, which protects the living from ultraviolet rays and puts a lid on the sky. So what does the air give to a tree? Carbon dioxide and water. Trees pull the carbon dioxide in through the same stomata that release the water. Carbon dioxide is the component in photosynthesis that gives form and shape to all molecules of life. It is the foundation of all life's fuel and all its structure, all its behavior. So all the solid flesh of the living has its origin in the carbon dioxide absorbed from the air. It is the power of the air that draws water through the trees. A small amount of water remains in the leaves, and this is the key to the first step of photosynthesis. The air may pull as much as 100 gallons of water through a single tree each day. That's a lot of circulation. So the stream from the ground and out into the air is driven by simple differences in pressure. Each stream stretches from a root to a leaf stoma. The water at the very end of the stoma forms a crescent moon of a meniscus where it meets the air. The intermolecular forces of surface tension hold this crescent moon in place against the sides of the stoma. On the surface of the crescent, the rising temperature supplies the heat to start evaporation, and so the first molecules of water break their bonds with the fluid and float off into the sky. And as they do this, they make space in the stream, reducing the pressure and increasing the tension. So water moves upward to replace what has evaporated, pulling the stream upward. And down in the roots, a few molecules of water are pulled in from the soil by the same temperature drop. So it's a constant Ini. It's a constant Ini.
Mm-hmm.
As the streams flow upward into the sky, driven by solar heat, there are moments of greater and lesser tension. And so during this phase, the carbon dioxide seeps in, and at the same time, a small amount of water is diverted to the food-making centers in the leaf. The water and carbon dioxide are used to make the sugars that will be the basis for the structure and the fuel that lets the tree live and grow. So the path from the stoma, root to the stoma, is a labyrinth. The channels of the streams are lines of cells called tracheids in conifers and vessels in the broadleaf trees. Each of these cells must die so the tree can live. The cells extend and link to one another by pits and valves and elliptical connectors that resemble air conditioning ducts. So do we wonder where we get all our stuff from nature? Combining into linked pipes, they climb the tree in lines, in zigzags, in spirals and circles. And when the channels are formed, all the cells die. Only then, when the insides of the cells have dried and decomposed, do the streams of water begin to flow through the network. The circulation that generates the power of storms, the oxygen for breath, the stratospheric shield, and the making of all flesh depends on this strange internal dead labyrinth of dead connected cells. The secret of their success is not to be ironclad and invulnerable. Rather, it is to be flexible, replaceable, and to create as many mutual connections as they possibly can. The air is a slow, cold flame. This statement partly notices that the very highly reactive element of oxygen has its primary reservoir in the air. And oxygen will react with just about everything else, and the reactions always produce heat and sometimes light. So most of the aerosols that rise into the air react with the oxygen there. So in that sense, the air is slowly, coldly burning. And the evidence of this slow, cold burn is rust.
Mm.
The greatest of all the oxygen reactions is the one in the present world that sustains most of the world's living beings. Respiration is a means by which creatures combine oxygen with carbon fuel to provide the energy to grow, hunt, feed, digest, defend themselves, heal themselves, and reproduce. So the common name for this is the process is the equation of burning. But where is the flame? A flame occurs when gas is excited and emits light of a particular set of wavelengths. In the air, the gases are excited. Liquids are vaporized and aerosols are sent aloft, either directly by solar energy or the solar energy that has been translated into work by the living. In the atmosphere, these gases and the aerosols meet incoming solar energy, bending and scattering it electromagnetically to produce the whole range of the hue, the chroma, the shadow, the intensity, and pallor in which we exist. So we and everything around us live in the midst of a slow, cold flame.
Wow. The flame of life.
Yeah.
Wow, and you end it like that?
Yeah, that's how it is.
That's a beautiful way to end it, huh?
Yeah.
Just involve it in just simple, nice ending, understanding of everything that you taught us with this. So this is starting to be a lot very technical. The last conversations are getting deeper and deeper into I don't know if to call it, because it's not really scientific knowledge. It's also empiric observation.
Right.
It's also which is very, very important to for us to observe and to understand and to base ourselves in the observation of the world we live in instead of beliefs that have been just planted in our minds of things that are not there. And so are we going to be going into the elements maybe?
Well, we're going to start next week with the secret life of water.
Okay, yeah. So that I guess right. Oh, wow. Secret and wow. I've been lately. I've been meditating a lot, or just having the thought in my mind of how liquid everything is. Like there's nothing really solid in the universe. Although I just learned recently that I don't know if it's true that metals in outer space will cold weld. They will weld together if they're just put together because there's no layer of air. The air is what makes two metals be apart. I didn't know that, and it seems pretty interesting. But then that's one of the amazing things that I've been, thinking of how the world we live in is so magical. Just the some of the things that we attribute to biology and all the wonders of biology are in fact wonders of chemistry. So so then everything that's even not a biological organism is still bound by these magical laws of life, right? And then you described air right now, and so we're gonna be diving deep into this magical world of that we can know about, and that we can certainly discover. And this is the place to know about it. This is the place where these conversations are being held. It's not at a college. In other places, they're not interested in knowledge. They're interested in money.
Yeah.
It's
Yeah, exactly.
So here we're beyond that. That the god of money, and that's why we can access all of this profound wisdom, and we can learn way more than if we go to a college, I believe.
Yeah. Oh,
Just like
absolutely.
being part of this. And so I invite you to join Aloha Nidao Living, where you will be getting a much better education if you do so. And not just that, but the opportunity to live in a freedom world. Is it too much? It's just too good to be true. But that's what the planet is. It's just too magical, too good, too beautiful of a place
Yeah.
to
So
be
not
true. And where it isn't true is in the economic world. That's where you
right.
cannot have that. You
Right.
cannot have a
Exactly.
planet.
A magical, living, breathing planet where everything is alive.
Yeah.
Yeah.
So join us to get there, to be there, to immerse yourself in this beautiful planet. And if you're not ready to join presentially, then join us in the next conversation next week, same time. The Secret Life of Water. Alrighty. So with that, we send you waterfalls of blessings. Please let us know you're alive, and we'll see you next week.